So look at the kind of expression we have, making use of addition and the subtraction, okay? Just like we have done something like this in the previous topic on algebraic fraction. But you know what I said, the previous example we did was that the numbers are down and the expressions are up. But this time around, we can have our expression both down and up, and we can also have it just at the denominator. So when you have a problem like this, the rules in addition and the subtraction of fraction is still applied here. And what are the steps and what are the rules? Just take your LCM in order for you to get a single fraction that this expression will be represented by. Now, let's take LCM. LCM of x and the x plus 2, that will give you x into x plus 2. So x into x plus 2 divided by x, I will have x plus 2. X plus 2 times 4, I'll have 4 into x plus 2 minus this divided by this, I'll have x times 6, that will give me 6x. So when you open your bracket, you have 4x plus 8 minus 6x over x into x plus 2. So like terms, 4x and minus 6x are like terms, so that will give you minus 2x. This one will give you plus 8. Then you now have x into x plus 2. There's nothing else we can do here. Remember, you cannot divide this because there is plus here that is adding to another number. So let's take example 2. So look at our second example. A plus B into over 2c plus d all square minus 3 over 2c plus d. Now, if you check that problem, our LCM is actually 2c plus d all square. So when this divide by this, we have 1. 1 times this will give you A plus B. Oh, A plus B minus, when this divide by this, I'll have one of these. One of these times this will give us 3 into 2c plus d. So open your bracket at the numerator. So that will give us A plus B minus 6c minus 3d all over 2c plus d all square. I don't think there's any other thing we can do there because there's no like terms, there's nothing we can cancel. So that's how we are going to have our problem or our answer. That's the way we are going to have it. So look at what we have: m plus n all square all over m square minus n square plus m square plus mn all over n square minus mn. Now, what you need to do here, before you take your LCM, you need to factorize, okay? You need to factorize your expression so that you can see the actual LCM, because you can't just take this and this as your LCM, okay? So let us factorize. So that will give us, here, I'll have m plus n into m minus n. So I will still have my m plus n all square plus, here I'm going to have n into m minus m, okay, into m plus n, okay. So you can see that there's something we can do here that will make this to look like this, okay. So that's to bring out minus outside here. So that will give us m plus n all squared over m plus n into m minus n. So when you bring out this minus here, that minus will change this plus. That will give you minus now into m plus n all over n into m minus n. Okay, remember at the beginning of this class, I have explained why whenever you bring out minus, the numbers will just interchange, especially when you have it in this nature. So if you look very well, you can see that our LCM now is m plus n, m plus m minus n, and n, because this one is repeating, so I don't need to repeat it, okay? So that will give us, you take your LCM, m plus n into m minus n into n. So that's our LCM. All everything I have here divided by this, I will have n. So that will give us n into m plus n square minus everything I have here. If I divided this, I'll have this. So this times this, that will give us m into m plus n all square. Okay, so you can see something is coming out from there. So let us finish it up here. So there's something common here. M plus n is common, so you can bring it out. So you have n plus n all squared. So when you do that, you have n there minus m, okay, all over. At the denominator, you have m plus n, m minus n, and n. Okay, so this one and one of these will go. Then I'll have to interchange one. Let me interchange this one. So that will give us minus m minus n over m minus n n. So this and this will go. I'll have this one will give us 1 here. So I have minus 1 over n. All right, so you can see how we have simplified this step by step. So the next thing to do is we are going to look at substitution. Okay, we're going to look at substitution where you are given a kind of ratio for x and y, and you are given an expression to put that value, or maybe when you are given x and you're asked to do substitution formula, something like that in the next example. Algebraic fraction, we call it substitution. There are two types of question they can ask you here. Okay, though this one can also be written in this form: x by ratio y equals to 3 ratio 4. So it's either is given to you this way or it's given to you this way. Okay, and you are now asked to use this information here and evaluate 2x minus y all over 2x plus y. Now, what are you going to do there? There are two ways to solve this problem. Okay, there's a way, I call it a kind of official way to solve it. Then I have other way of solving it that is a lot simpler to solve. Okay, so I'm going to solve that method first. Then I'll now use the method that is let me use the word official, because most times in if this problem comes out in the theory part, most examiners will expect you to solve it in that special way, a kind of. Okay, but there's a shorter way of solving this. So let me use the shorter way first. So I have my solution. So if you say that x over y equals to 3 over 4, it means that x is 3 and y is 4. Okay, so if I have to take it that way, that x is 3 and y is 4, then I'll just put it here. Therefore, 2x minus y over 2x plus y, that will give me 2 into 3 minus 4 all over 2 into 3 plus 4. So that will give us 6 minus 4 over 6 plus 4, which is equals to 2 over 10, which is equals to 1 over 5. So you can see how simple that one is. Okay, but let us do the one that you see most of the textbook doing, which most of the examiners will want you to do. Is not that simple as this, but it's also very simple to do. So using the second method now, so what are they asking you to do? You see this expression given, 2x minus y over 2x plus y. You are going to make this expression to have a term like, or have an expression like x over y. So how can you make that, or how can you achieve that? If you divide each of these expression or each of these alphabet here by y. because y is at the denominator, I think we are going to have our x over y. So let's try that. So 2x over y minus y over y all over 2x over y minus y plus y over y. So that will give us 2 into x over y minus 1 all over 2 into x over y plus 1. Okay, so you can now put your values of x over y. So that will give you 2 into 3 over 4 minus 1 all over 2 into 3 over 4 plus 1. So that will give you, this and this will go. I have 3 over 2 minus 1 all over. This will give you 3 over 2 plus 1. So what would that give you? 3 over 2 minus 1 will give us 1 over 2 divide by, that's all over. 3 over 2 plus 1, that will give you 5 over 2. So change that, you have 1 over 2 times 2 over 5. So 2 will cancel 2, you have 1 over 5, which is the same thing with what we have here. So let me explain this again. I'm giving x over y equals to 3 over 2, and the problem I'm asked to evaluate is 2x minus y all over 2x plus y. What do I need to do? You have to make sure that the x over y you are given, you have it in your expression, and to achieve that, each of the variable here, I'll divide it by y. So divide the first one by y, second one by y, come to the denominator, divide it by y, and also divide the second term by y. So that will give us 2 into s over y minus 1, 2 into s over y plus 1. And when you put your value of s over y, which is 3 over 4, you have 2 into 3 over 4 minus 1, 2 into 3 over 4 plus 1. So when you divide these 2 and divide these 2, you have 3 over 2 minus 1. Do the same thing here. You have 3 over 2 plus 1. And 3 over 2 minus 1 will give you 1 over 2. And you have your minus 1. Okay, 3 over 2 minus 1 will give you 1 over 2. And 3 over 2 plus 1 will give you 5 over 2. Remember, all over means divide. So you can change the divide to multiplication. The denominator of this one will come up. The numerator of this one will come down. So you have 1 over 2 times 2 over 1. So 2 can cancel 2. You now have 1 over 5 remaining. Okay, so let us solve the second kind of problem that we normally have under substitution and see the dimension and see the kind of problem that will give us. We have x equals to 3m minus 5 all over 3m plus 5, and you are asked to express this in terms of m. What are you going to do? It's very simple, okay? But you need to be careful. Make use of brackets where needed, okay? What are they asking you? Just anywhere you see s, replace this so that whatever you are going to have as your answer, everything will be in terms of m. As simple as that. So let us see how we can solve that. Anywhere I see x, I will replace this. So the first thing I will do is to put all these things inside brackets so that I will not be confusing myself. Okay? So solution, that will give us 3m minus 5 over 3m plus 5 minus 1, that's the numerator, all over 3m minus 5 over 3m plus 5 plus 1. So my job now is to solve this, and I'll get my answer. Okay, so let us partition our board because it might take a longer than what we had before. So let's solve this. Now, this one is not a fraction. Remember what I normally say, that if you have a problem that involves a fraction and there's a number there that is not a fraction, make it a fraction. Make it a fraction. Okay? So if you make this one a fraction, you now take what? LCM. When you take LCM, you simplify the numerator, you simplify the denominator. Let's do that. So that will give us the numerator, the LCM is 3m plus 5. 3m plus 5 divided by 3m plus 5, I will have 1. 1 times this will give me my 3m minus 5 minus 3m plus 5 divided by 1 will give me back my 3m plus 5. Then I'll multiply by 1. That will give me 3m plus 5. So this is my numerator, okay? All over my denominator now, that will give me 3m plus 5 as my LCM, okay? So 3m plus 5 divided by 3m plus 5, that will give me 1. 1 times 3m minus 5 will give me 3m minus 5 plus 3m plus 5 divided by 1, that will give me 3m plus 5 multiplied by 1, that will give me 3m plus 5. So simplify the numerator, simplify the denominator. So that will give us 3m minus 5 minus 3m minus 5 all over 3m plus 5, okay? Divide by, I'm taking this over as divide. So divide by, do the same thing here. 3m minus 5 plus 3m plus 5. I've opened this bracket all over 3m plus 5. So you change this one to multiplication. So that will give you 3m. Oh, 3m will go. Minus 5 will give me minus 10 over 3m plus 5 times. This one will come up now. So I have 3m plus 5 all over. Minus 5 plus 5 will go. I have 6m. That's 3m plus 3m. So 3m plus 5, 3m plus 5. 2 here, 5. 2 here, 3. So our answer is minus 5 over 3m. As simple as that. Okay. So this is where we are going to end this class on substitution. So the next thing we are going to do is algebraic fraction or algebraic equation involving fraction. Algebraic fraction involving equation, whichever one. So we are going to have an algebraic fraction that we are going to solve this time around, because there will be a equality sign, and whenever there is a equality sign, we are expected to solve to get a value for our variable. So let us move into that and see how that goes. So what we have on the board is an algebraic equation, okay? But this one is very simple. So we're not going to take time to solve it. Then we'll move to another type, okay? Let me just tell you what to do. Yes, I know that most of you watching now, you want to cross and multiply. That's a very good idea. That's a very good way of solving. But whenever you have a fraction that whatever you have at the numerators are the same, it simply means that the denominators are the same. If the numerators are the same, the denominators are the same. That's what we apply there. So it's as simple as ABC. So since this is equals to this and 3 equals to 3, therefore C minus 2 equals to what? 2C minus 5. You collect like terms. As simple as that. This one move over here. This one come over here. Minus 2 plus 5 equals to 2C minus C. These two will give us 3. These two will give us C. Therefore, C equals to 3. As simple as that. Okay. So let us move to example 2. So there's no waste of time in that particular type of question. It's a very simple question to solve. You can cross and multiply, you will still get the same answer as C equals to 3. But so long as the numerators are the same, the denominators are equally the same. Okay, so let's move to example 2. So see what we have here. 2m plus 3 over 2m plus 5 minus m minus 1, m minus 2 equals to 0. Okay, so what are we going to do here? Okay, take this one over here and cross and multiply, or take the LCM of the fraction, make this a single fraction, then you cross and multiply. Whichever way, you get the same answer. But let me take this one over here, since there is nothing here already. So let me take this over here and cross and multiply. So that will give me 2m plus 3. I'll put in brackets. I always say that, put in brackets, over 2m plus 5 equal to m minus 1 over m minus 2. So at this point, I will cross and multiply. If I cross and multiply, that will give us 2m plus 3 into m minus 2 equals to m minus 1 into 2m plus 5. So open your bracket. So that will give you 2m squared. This and this will give you 2m. Oh, 4m. This and this will give you plus 3m minus 6 equal to this and this will give you 2m squared. This and this will give you plus 5m minus 2m minus 5. So when you simplify this, meanwhile, I can see 2m squared here. I can see 2m squared here. So both of them will cancel out. So these two here will give me minus m minus 6 equals to these two here will give me 3m minus 5. Okay, so you collect like terms. So I take this one here and I bring this one here. Okay, you'll be surprised the way I'm doing all this is because I like keeping the bigger variable and bringing the smaller variable. Okay, so that I won't be battling with my negative value. So with that now, I have minus 6 plus 5 equals to 3m plus m. So this one will give me minus 1 equals to 4m. So divide both sides by 4, minus 1 over 4 equals to 4m over 4. Therefore, m equals to minus 1 over 4. Okay, so that's how we solve that particular problem. So let us also move to another example, probably our last example on fraction. Okay, so look at what we have here. So what are we going to do first? Make everything a fraction, take LCM, get a single fraction, cross and multiply, then you have your answer. Okay, let's try that. So that will give us, make this one over 1. So 4a minus 1 over a plus 4 minus 2 over 1 equals to 2a minus 1 over a plus 2. So that will give us LCM here will give us a plus 4. I like putting in brackets. So a plus 4 divided by this will give me 1. 1 times this will give me 4a minus 1. Minus this divided by this will give me this. This times this will give me 2 into a plus 4. Okay, so I have done that equal to, this side is already a single fraction. Okay, so the next thing is to take care of the numerator of this one. So that will give us 4a minus 1 minus 2a minus 8 all over a plus 4 equal to 2a minus 1 over a plus 2. All right, so we still have something to do here. So let's finish up. So this and this will give us 2a. This and this will give us minus 9 over a plus 4 equal to 2a minus 1 over a plus 2. So at this point, we can now cross and multiply. So let's do that here. So when you cross and multiply, you will have that 2a minus 9 into a plus 2 equal to 2a minus 1 into a plus 4. So let's open our bracket. That will give you, this and this will give you 2a squared. This and this will give you plus 4a. This and this will give you minus 9a. This and this will give you minus 18 equal to, this and this will give you 2a squared. This and this will give you plus 6a. This and this will give you minus a. This and this will give you minus 4. Okay, so you can see 2a squared, 2a squared can go. So these two here will give us minus 5a minus 18 equal to, these two here will give us 5a minus 4. Wow. Okay. So, like I always do, the smaller variable come here, the number move out. So that will give us minus 18 plus 4 equal to 5a. This one come over here plus 5a. So this and this will give me minus 14 equals to 10a. So divide both sides by 10. So that will give us minus 14 over 10 equals to 10a over 10. This and this will go 5, 2, 5, 7. Okay, so that will give us that minus 7 over 5 equals to a. Therefore, you can say that a equals to minus 7 over 5. Okay, so you can see how the problems are being solved. Okay, so whichever problem you have under algebraic equation involving fraction, you follow the same way. Take LCM, get a single fraction at the left-hand side, a single fraction at the right-hand side. You cross and multiply. So whatever you are going to do to get a single fraction at the left-hand side or right-hand side, you have to do that probably by taking LCM or whichever way, other ways that you can be able to do that. So when you get a single fraction, you cross and multiply. When you cross and multiply, you just solve your problem. Sometimes it can also lead to quadratic. You can see each time we want to get quadratic, we will not get the same thing and cancel out. Not every question will actually cancel out like that. So some questions, it might lead to quadratic. We solve our quadratic and still get our answer. Okay. So the last segment of this topic, okay, the last segment of this topic is when we say undefined. When you are given an expression and you are asked at what value of the variable will make the expression to be undefined. Okay, so let us have a sample of such question, then we explain what undefined means in mathematics. In mathematics, when we use the word undefined, it simply means that that expression will not exist. So when they say the value of x for which the following is undefined, they mean what value of s are you going to put in this expression that will make it not to exist? When we say not to exist, probably you are using calculator to solve, you are going to have mathematics error or math error in your calculator. Okay, so that's when you get things like this. That's indefinite. Okay, means that that expression is undefined. You cannot find it. We can't ascertain the value. Okay, is undefined. Okay, for example, if we have 1 over x, you will notice that if we put x at 0, if we make x 0, we are going to have, okay, let's say we let s equal to 0. This thing is going to give us 1 over 0, and 1 over 0 is what? Indefinite. That means this fraction here is undefined at s equals to what? 0. Now, what is the idea? The idea is that whenever you have a fraction and you're looking for the value of your variable that will make that fraction to be undefined, the secret is just to go to the denominator and equate it to 0. So the values of the variable where the denominator will be 0 makes it what? Undefined. Or if it's a square root, the value of x that will make this expression to be negative will be what? Will also be undefined. It will not exist within the real numbers for this one, okay? But this one will not exist at all. Both are the real numbers and complex numbers, okay? Though at this one will exist at the complex line, but it will not exist on the what? On the real line, okay? So we are going to focus only on this type of problems where you'll be given a quadratic an algebraic fraction and you are asked to find the value of s that will make it what? Undefined, that will make it not to exist. Okay, so the trick there is just for you to do what? Get the denominator, equate it to 0, and find the value of x or y or whichever value or whichever variable that is used that and when that denominator is equal to 0. So find the value of that variable. That's the point that that fraction will not be what? Defined. So let us solve few examples on this, then wrap up the topic. So like I explained before, at what value of x will make this denominator to be equal to 0? That's the point that this expression will not be defined. Okay, so what are we going to do? So let's write solution. So 7 over x minus 3 is undefined at x minus 3 equal to 0. Therefore, s equals to what? 3. So at s equals to 3, this fraction will not be defined. Okay? It will not exist. It will give you an indefinite number. And that's what it means by being undefined. So let's look at another example 2. Example 2 is not different from example 1. All we need to do is to equate the denominator to what? To 0. So that will give us x plus 4 into what? X plus 3 equal to 0. Therefore, x plus 4 equal to 0, or x plus 3 equal to 0. So that will give us that s equals to minus 4 or s equals to minus 3. Therefore, at s equals to minus 4 or s equals to minus 3, the expression will be undefined. So you can see how simple that is. So let's solve one more problem on that and conclude the topic. When you have such expression, you can see that this one is not a single fraction. Okay, so when you have an expression that is not a single fraction and you are asked to find the value of x that will make it undefined, so what you need to do is to simplify this. First of all, put it as a single fraction. When you have done that, you now equate the denominator to 0. You can't equate the denominator to 0 like this. You need to do what? Simplify. So let us simplify. This one will give us 18x plus x squared plus 1 over x minus 3 into x plus 3. Of course, that's difference of two squares. Okay, so that will give us x into x minus 3 into x plus 3. Then this divided by this, that will give you 18 into x minus 3 into x plus 3 plus x squared plus 1 into this divided by this will give us x. Okay, so of course we don't care about what happened at the numerator. Our interest is always at the denominator, because there's no value of s you can put here that will make the numerator not to exist. But immediately the denominator is 0, the whole expression will cease to what? Exist. So when you equate x, therefore s minus 3 into x plus 3 equal to 0. Therefore, s equals to 0, s equals to minus 3, and s equals to 3. So these are the points at which this expression will not what? Exist. Okay. So the lesson to learn here is that whenever you have a fraction that is not a single fraction, you first of all factorize. Okay, then take your LCM, put it in a single fraction before you now equate the denominator to 0 to find those points at which the expression will not exist. Okay, so this is a very long one. Okay, I also try to see if I can finish the whole of this topic in one video. I hope it will be in one video. Okay, so that when you take up the lesson, you can be able to just finish it up at once. So we are going to end the class at this point. Please do well to give our video a thumbs up, share our video, and please, if you are yet to subscribe, subscribe to our channel. Okay, so more and more is coming your way. I remain Mr. Dennis, your math teacher. Thank you so much for your time. See you in the next class.